Hi guys, in this video we're going to work our way through this practice 2.2 through 2.5. I'm going to go kind of quickly, but remember that you have the option to pause anytime that you fall behind and need to get caught up. But first you should definitely try to do these on your own and then watch the video if you need help or just to even check your work. Okay, so I'm going to start out with number 1 here, and this is, we're going to do long division for this problem, and this one's kind of tricky because, well, you'll see. So our divisor is x plus 2, and our dividend is this x to the 4th, which has a 4th, that's the 4th degree term. And then we have plus 2x to the 3rd, and notice there is no 2nd degree term, so you need to keep your eye out for missing terms. So here we have to add in a placeholder, essentially, of 0x squared, and then I have minus 3x, and then plus 1. Okay, so long division, what you're going to be looking for here is we're going to look at this x, the first term in the divisor, the first term in the dividend is x to the 4th, and you have to think, okay, what do I have to multiply x by to get x to the 4th? And the answer is x to the 3rd. So then we multiply x to the 3rd times our divisor. If you have not watched the videos on how to do long division, you should probably stop and watch those first and then come back to do this. Okay, so we're going to distribute the x to the 3rd, and we end up with x to the 4th. And we're going to put this right underneath here, x to the 4th plus 2x to the 3rd. And so before I said this one's a little bit unusual, and the reason is when I take 2x to the 3rd and I have to subtract these terms, so I'm going to subtract 2x to the 3rd, I'm going to end up with 0x to the 3rd. That's not usually going to be the case. And so I'm going to put a placeholder here. I could just say it's 0, but I want to put a placeholder here so I don't miss anything. We designed it so the first term would cancel out, x to the 4th minus x to the 4th. That's why we chose to multiply by this. But now let's look at this x again, and we have to figure out what we have to multiply by to get 0x to the 3rd, and the answer is 0x squared. So now if I multiply, oops, I forgot to drop this term down, and again this is why it's extra unusual because I have a 0x to the 3rd plus a 0x squared. But just treat it like any other number. If I multiply 0x squared times x plus 2, distribute that, you're going to get 0x to the 3rd plus 0x squared. Yeah, 2 times 0 is going to be 0x squared. And now when we subtract again, we're going to get 0x squared, and I'm going to drop down this minus 3x. Oops. And I have to think, like, what do I have to multiply x by this time to get 0x squared, and that would be 0x. So I'm going to multiply 0x times x plus 2, which is going to be 0x squared plus 2 plus 0x. 2 times 0 is 0. So I have 0. Oh, I'm running into my other problem here. I definitely didn't leave enough room. Sorry about that. And now we're subtracting. So I have a negative 3x minus a negative 0x, which normally you would add, but because it's 0, we don't have to do that. And I get a negative 3x, and then I have to bring down my plus 1 here. And so now I have to multiply, put that one orange here, I have to think, what do I have to multiply x by to get negative 3x? And the answer is minus 3. So if I do negative 3 times x plus 2, I'm going to get negative 3x when I distribute, and then minus 6. And recall that we're going to go 1 minus a negative 6, which ends up adding 6, so we end up with 7. And x cannot go into 7, so this is my remainder. So when you write the answer, your quotient here, this is our quotient, you're going to write it as quotient plus the remainder over the divisor. So our answer will be, I don't need to include all those 0x's, so I have x cubed minus 3 plus I got a 7 over the divisor is x plus 2. All right. Number 2 is definitely, we covered this in like last week sometime. This is end behavior of a polynomial. And what you need to look for when you're talking about end behavior, and we want to write that in limit notation, you're going to look for the degree of the polynomial, and you're going to look for the lead coefficient. The degree of this polynomial is the term that has the highest power, and this is in descending order, so it's going to be that first term. The degree is 5, which is odd, which means the ends of my graph are going to go in opposite directions. Odd degree goes in opposite directions, and the direction it's going to take depends on the lead coefficient, which is my lead coefficient. We're just looking to see if it's positive or negative, and in this case it's a -3, so a negative lead coefficient means the ends of the graph, I don't know what's happening in the middle. It can have up to 4 twists and turns because it's a 5th degree polynomial, but I do know that the ends are going to go off like that. They're going to be going in, if you think of like I connected that as a line, that would be a negative slope. It's when the lead coefficient is negative, it's going to have that end behavior. And the way that you write that in limit notation is limit of f of x, we abbreviate limit as lim, and we're going to say as x goes to infinity, and that's right underneath the word lim. It's either, for all polynomials, the end behavior is going to be positive infinity or negative infinity. So let's look at what's happening when x goes out bigger and bigger and bigger. The y values are going farther and farther down towards negative infinity. And conversely, the limit of f of x as x goes off in the other direction towards negative infinity, those y coordinates are going up, and so they are approaching positive infinity. All right. So our next question here, or the next step, is to divide using synthetic division, and we're going to write our answer in the same format: quotient plus remainder over divisor. Again, if you haven't watched the video on synthetic division, you should do that before you do this problem with me. So what we're going to put in this little box here is we look at our divisor, and you have to decide what would make that equal to 0, and the answer is 1. So you're going to put a 1 in that little box. And then we're going to list all of our coefficients here, and again, remember to put in a 0 if there's any missing terms. We have a 4th degree, 3rd degree, 2nd degree, 1st degree, and 0 degree, so there's no missing terms in this case. So we're going to write a 1 for this coefficient here. The next coefficient is a -2, and then we have, and leave room in between these coefficients, a 1 again, and then this is going to be a -3, and then we have a 1. And for synthetic division, you're going to just drop your first term, and then we multiply 1 times 1, and we write that result right underneath here, and then you add, and then we're going to repeat that process till we get to the end. -2 plus 1 is going to be -1. Multiply the 1 times the -1, you get -1. Add, you get 0. 1 times 0 is 0, and then if I add, I get -3, and then 1 times -3 is -3. Add, and you get -2. That last number will always be our remainder, and because we have a remainder, that means that x minus 1 is not a factor of the polynomial. If it was, we would have a remainder of 0. And that's how you can determine if something is a factor of the polynomial or not. When you do the division, if you get a remainder of 0, it is a factor. So my remainder is that. This is going to be, these numbers here represent the coefficients of my quotient. And we start out, this -3 here is my constant. And this is going to be my x term. So we're going to have 0x. This will be my x squared term. So we'll have a -1x squared, and then x cubed term. So 1x cubed. So we have, my quotient is 1x cubed, which I can just write x cubed, minus x squared, 1x squared, plus 0x, which I don't need to write, and minus 3, plus the remainder over the divisor. Okay, we're going to stop there for right now.